Hello everyone. Hope you're all well. Let's get into O-level physics. Lesson 8 is atomic structure and radioactivity. An atom contains a small positively charged nucleus of protons and neutrons with electrons around it. Proton number Z identifies the element, nucleon number A is protons plus neutrons. Isotopes have the same proton number but different neutron numbers. A neutral atom has equal protons and electrons, while an ion forms by electron gain or loss without changing the nucleus. Unstable nuclei decay randomly and spontaneously. Alpha is a helium nucleus, beta- is a fast electron produced when a neutron changes to a proton, and gamma is high-frequency electromagnetic radiation. Alpha is strongly ionizing and weakly penetrating, beta is intermediate, gamma is weakly ionizing but highly penetrating. Paper stops alpha, thin aluminium absorbs much beta, and thick lead or concrete reduces gamma. In alpha decay, A decreases by 4 and Z by 2. In beta- decay, A stays constant and Z increases by 1. Gamma emission changes neither number. Nuclear equations must balance nucleon and proton numbers. Electric or magnetic fields deflect charged alpha and beta in opposite directions, with beta deflecting more because of its much smaller mass. Gamma is undeflected. Background radiation comes from cosmic rays, rocks, radon gas, food, living organisms, and medical sources. A GYGER Muller tube measures count rate. Corrected source count equals measured count, background count. Count fluctuates because decay is random, so measurements should cover sufficient time and be repeated. Safety uses minimum time, maximum distance, shielding, tongs, and secure labeled storage. Half-life is time for undecayed nuclei, activity, or corrected count rate to halve. If corrected count starts at 800 counts minute and half-life is 6h, it becomes 400, after 6 hours, 200, after 12 hours, and 100, after 18 hours. Exponential decay has equal fractional decreases in equal half-lives, not equal numerical decreases, and activity theoretically approaches zero. Radioisotopes are selected by radiation and half-life. Medical tracers need detectable penetrating radiation and a sufficiently short half-life. Thickness gauges use beta absorption, smoke detectors use ionizing alpha, radiotherapy uses penetrating radiation to damage cancer cells. Every use balances benefit against cell damage. Contamination puts material on or inside an object, while irradiation exposes it without necessarily leaving radioactive material. Balance A and Z in nuclear equations, subtract background before half-life work, count the number of halving intervals, and match source type and half-life to its use and risk. Measured count is 460 counts minute and background is 60, so corrected count is 400. After 3 half-lives it is 400 all over 2 to the power of 3 equals 50 counts minute. Measured count would then be about 110 including background. Do not say isotopes differ in protons, treat gamma as a particle with mass number, subtract background after halving instead of before, or confuse irradiation with contamination. Practice. A corrected count is 640 counts minute with half-life 5 days. Find it after 15 days. Answer: 3 half-lives, 640, all over 8 equals 80 counts minute. Watch the numbers land in the matching symbols. Check that units cancel cleanly. If they do not, the setup is wrong even before the arithmetic. Practice. A source reads 270 counts minute with background 30. After 8 hours it reads 90. Find half-life. Answer: corrected rates are 240 and 60. A fall by factor 4 equals TWO half-lives, so half minus life equals 4h. Watch the numbers land in the matching symbols. Check that units cancel cleanly. If they do not, the setup is wrong even before the arithmetic. Alright, that wraps up atomic structure and radioactivity. Coming up next in O-level physics, practical skills, uncertainty and exam data analysis. Hope that helped. Catch you next time.